So, before starting with the load balancers, okay. So first of all, although I'm showing you this UI here, so I'm not saying that I'm going to skip something from the course. Might be some things can be, I mean, let's say the serial of the topic can be changed depending on the flow that we are going. Let's say in IAM, I have uh, kept on hold some of the things that we are going to discuss in the coming days. Why we have, because you will, although let's say if I cover up the whole IAM thing in the one goal, then what will happen after some time, you will not able to recall the thing. The same way we have followed this thing in Linux as well, in I would say shell scripting as well. Let's say in Linux, I kept SED on hold for some time, but at the same time, when we started working on the shell scripting, we introduced the SAD there. So in this manner, we are going to cover up now, guys. There is a one important thing that we are going to discuss. One is load balancer and the auto scaling. People generally confuse with the name. Let's say whenever I'm discussing that, okay, we are going to start the load balancer, so people think that uh, most of the people are get confused at the very first time when they are discussing about the load balancer, that this load balancer might be related to the load of the Linux servers that we are getting. Let's say they are, I mean, balancing the load of the server, but no, that's not true. The main use case or the objective of a load balancer is to route your traffic to your different instances, depending on the rule, depending on the availability of the resource, and depending the configuration that we have done, which we can say depending on the rules that we have covered. Okay. So guys, when I click on the load balancer, although before the cloud era, load balancers are also hardware based load balancer. So this, in AWS we are using the I mean self managed, or sorry, AWS managed load balancer. So under load balancer there are different categories available. So when I say different categories available under the load balancer, first of all, this one, initially they were few are the load balancers. Okay. So the first one was classic load balancer. Classic load balancer. Okay. Then we have the application load balancer. Application load balancer. The third one is our network load balancer. Network load balancer. So these are the initial load balancer which were available in the market. Guys, just a second. Let me just connect. Yeah. So the load balancer is classic load balancer, application load balancer, network load balancer. Okay. So initially, these are the three load balancers that are majorly being used in AWS. Right now, if we say, when we click on the create load balancer, now we have another load balancer, which is a gateway load balancer. So what is this load balancer? We are going to discuss. And here you can see that we have the classic load balancer, which is of the previous generation. Okay. So that definitely there are some disadvantages of classic load balancer, which makes this load balancer is an absolute obsolete one. Okay. So let's say the another load balancer is your fourth one is your gateway load balancer. Okay. Now, guys, this load balancer thing is very important for you. Let's say if I earlier when I have asked the question, remember guys, I have asked a question. Let's say when you hit a URL of a server, let's say whenever you are trying to access a website, it is giving you some error. Okay. Now, uh, you will be little bit confused that okay, we need to debug the server. But let's say once the load balancer is introduced, then coming onto the server is the next part. Before that, we need to jump onto the load balancer and need to check that whether our server is running fine, or whether our load balancer is running fine or not, whatever the configurations we have given for the load balancers are correct or not, also all these things. Okay, so these are the load balancer: classic load balancer, application load balancer, network load balancer, and gateway load balancer. So before jumping in or before doing the deep dive under the load balancer, guys, I have uh, in the Linux chapter we were discussing the OSI model and TCP/IP model. Remember the 7 layer and 4 layer architecture we have discussed. So according, let's say, what is a application state in network topology and what is a network state or network stage in network topology. For transmitting our data from one layer to another layer, we require the network layer. Okay. Whereas if I say the application layer, under the application, what I have to do, let's say if I want to establish the communication between two different application, not application layer, two different application. Let's say one is your GCP, another is your AWS. Now I want to establish the connection between them. Now definitely I required a method to connect with these two applications. So those applications are going to be work on the application layer, because we are going to create some kind of a rules over there. Okay, so this is the major difference between the application layer and network layer. Guys, this is not the difference between application load balancer and network load balancer. No, this is the difference between application layer and network layer. You are unable to recall it, that is why I'm helping you out there. Okay, now first of all, uh, here you can see that we do have different load balancer. Let's say application, network, gateway, classic load balancer. So as a DevOps engineer, your team is going to ask you, okay, now listen to this very carefully, guys. Your team is going your team doesn't know anything about the application load balancer, gateway, or whatever the four load balancers we have. Now also, apart from this, I wanted to highlight one more thing. These load balancers, let's say classic load balancer, your gateway load balancer, network load balancer, and application load balancer, these are available in AWS with this name. But in GCP, they will be with some different name. In Azure, they will be with some different name. But the concept, the logic, and what the target that you want to achieve will be same in all the uh, cloud vendors. Getting my point? So you have to just catch up the concept here. Once you get the concept, you can easily configure any kind of a load balancer in any type of cloud vendor. Okay. Now let's say the classic. First of all, I'll say the classic load balancer. So before this, let's try to create our load balancer. Okay. Now what is this and how to achieve this? I'll tell you. So first of all, give the load balancer name. Now I'll give my underscore first underscore CLB, that is your classic load balancer. Now it is asking for a scheme which is internet facing and internal facing. Now the difference between internet facing and internal facing load balancer is when you want to expose your load balancer directly with the external world. I'm repeating, when you want to expose your load balancer directly with the external world so that anyone can easily access your load balancer, that thing is called internet facing load balancer. Okay, whereas you if you do not want to expose your load balancer to the external world, then such kind of a load balancers are called internal load balancer. Remember guys, once you create the load balancer and whatever the scheme you have select, you cannot modify your scheme. Let's say by mistake, I mean, you got a ticket where you need to update, where you need to create the internal load balancer, but somehow or by mistake you have created the internet facing load balancer. Then in that scenario, you have to delete the complete load balancer, and then you can create a new load balancer with the requisites, or with the thing, I mean, the configurations that you want. Okay, just uh, This is not just the must thing, it is the backbone of every infrastructure, Suman. So that is why I was emphasizing, I was forcing you to just clear your all concepts related to the cloud and EC2 instances. Okay. So why load balancers are must? First of all, let's say, Suman, what happened in AWS in production, the way we are creating our instances, we are deleting our instances, the things don't go in that manner. Although we are covering the basic over there, but the things actually how the things are going to work in the production scenario, now we are going to discuss as we have started the load balancer thing. What happened? Let's say I'll show you the uh, draw.io. Okay, now how generally your so guys, this is the website from where you can create your network diagram, because as you are a DevOps engineer, it is also your responsibility to have your network diagram. Okay, so how the things generally work, I'll tell you. Let's say this is your user. Okay, this is your user. Consider this thing as not an actor. You can say that this is your user. Now what happened? Just select the thing that you want, line one. Now this is your line. I'll tell you this thing in more details, but let's say your user wants to access www dot let's say networkings.com. Okay, your user wants to access this thing. Now what happened in the background, as I already told you, that whenever we are hitting this website or any website, not only single server is working behind it, there are multiple servers running, multiple services are running. Okay, now this is the actual prod scenario I'm showing you right now. Okay, so this thing means your user is trying to access www.networkings.com. Now what happened is, here, let's say this is your AWS infra. Okay, this is what, this is your AWS infra. Okay. Now, what happened? Under your AWS infra, there are some internet gateways are attached. So many things are there. Okay. Let's say AWS. Now, what happened? After that, yeah, yeah. Now, what happened here? These are your load balancer. Your requests are going now here. What is happening actually is, and now what is happening when your user is trying to access this networkings.com, actually this is not the uh, URL of this load balancer. This is the URL that we have assigned with our load balancer. Now this is your load balancer. This load balancer will have its own DNS, its own DNS. Okay, so this is the we generally have the DNS of any load balancer. Now, under this load balancer, what is actually happening in the background is, let's say, line. Okay, this is your load balancer. Now, under your load balancer, there are different instances attached with it. How do they are attached? Is your now here. Let's say this is your one line. This is your second line. Now here E2, your EC2 instances are behind your load balancer. This is EC2 instances. These are your EC2 instances. Now, this is not a single EC2 instance, guys. This is your multiple EC2 instances. Now, what happened? Let's say for a single application, we have created more than 2 application servers. Okay. So, what will happen? Those all application servers will be attached behind a load balancer, and once these are attached, from now onward what we are going to do, we are going to map the DNS of this load balancer with some random uh, DNS, and whenever anybody is hitting this URL, what is happening in the background, let's say if I'm hitting www.networkings.com, my request is first going on to my load balancer. If any third party, let's say Nginx or n number of third party tools are there, are not in the mid, so directly my request is coming on to my load balancer. Now, if you have created your load balancer as a internet facing, then directly you can access it. But if it is an internal facing load balancer, then definitely there is some another medium between this. Now, we have to configure our rules inside this load balancer. That, let's say if my request come as networkings.com. Okay, so guys, let's say if my request comes not like this, consider an example as uh, okay, not okay, let's say now what will happen, uh, if I hit NW Kings. So what will happen after this, when I click, let's say this is my untitled. So if I, or let's consider this thing, when I click on here, you can see slash whiteboard.htm. So this slash whiteboard.htm is not just single string. It is actually representing your rule that you have configured inside your load balancer, that if anybody hits this URL, so redirect my traffic to this load balancer group. If anybody hit this URL, or let's say this URL index.htm, hit this load balancer. So in this manner, guys, your load balancers actually managing your whole infra. Now consider a thing that you do not have this load balancer here. Okay. Now just tell me www.nwkings.com. I have 25 servers. So I require 25 domains, correct or not? Now, let's say, sorry, I forgot what I was doing. Yeah. So here we have to select the VPC. Now, guys, uh, always, although you will get the already created infra whenever you are joining any organization, but if you are creating an infra from the scratch, always create different VPC for your load balancer. Always create different VPC for your database. Always create different VPC for your application servers. Do not create a single VPC for all the applications, because it is going to because database is going to consume its own IP. Load balancers are going to consume their own IP, and each and every AWS resource is having some kind of a soft limit and hard limit. So it is good practice that you are creating the database services into different VPC, application services into different VPC, and load balancers into different VPC. Okay. Now, let's say we are selecting our VPC. Now, what kind of a mapping we required? Whether this one, okay. So this thing is called the multi-availability. How? Because I am launching my application into different availability zones. The security group. Now, guys, the security group of load balancer is different, and security group of your application or EC2 instance is different. Please do not select the, although, because as you are creating the different VPC for all these different sources, so you won't be able to select the same security group. But do not, I'm again repeating, please don't get confused in this thing. Security group for load balancer is different, and security group for EC2 instance is different. Okay. Now here, now this part is called your configuration of load balancer. Here you need to mention that what configurations I need to have for my load balancer. Now this thing says that listener and routing. It is saying that on which protocol your load balancer is going to listen your traffic. Okay, remember I have already told you that in Linux or in any network topology, all the traffic listens on some specific port. So we have 4 ports available: HTTP, HTTPS, TCP, and SSL. So these are the protocols. Let's say my load balancer will listen on HTTPS port. Now this will be your port on which your application is running on your EC2 instance. I'm repeating, listener HTTP. This means your on which port your load balancer will listen your request. Let's say this part will listen on which request. Let's say this listen on the port 443 and it's, whereas this thing means on which port your application is running on the server. Let's say when you do netset TNLP, so is it port 80, port 22, port 25, port 443, whatever the port is, just mention your port here, because your load balancer is going to check the port on the server only. It is not going to check the name of your service. No, it is going to check the port, that whether this port is alive or not on your server. If it is alive, it means your application is running. If the port is not alive, it means your application is down on your server. Okay. Now, let's say security policy. As I told you that we are implementing HTTPS, which is an secure version. Let's say if I select the HTTP, I'm not going to get the SSL here. Okay. Now, ping protocol. On which protocol your load balancer will ping your EC2 instance, and on which path? Now, this ping path is actually your health check URL, which is called your health check URL. This URL is generally being provided by your developer team, that I want my health check URL as this one. You just need to configure it. Okay. Select the instances that you want to. ये URL आपका EC2 इंस्टेंस पे कॉन्फ़िगर्ड होगा, और ये जो रोल, ये जो इशू, ये जो पिंग पाथ देना होता है, ये आपकी डेवलपर टीम देती है, क्योंकि वो अपने कोड में मेंशन करके रखते हैं इसको कि यार मेरा पिंग पाथ ये होना चाहिए। अब मानो आपकी वेबसाइट डाउन होती है, तो आप उनको ये बोलोगे कि भाई तुम्हारा हेल्थ चेक यूआरएल यही है ना। अगर वो बोलते हैं हाँ यही है, तब आपको और कुछ चीज चेक करनी पड़ेगी। अगर वो ये बोलते हैं नहीं हमारा हेल्थ चेक यूआरएल ये नहीं है भाई, तो यू नीड टू चेंज द हेल्थ चेक यूआरएल। ओके। नाउ बेसिकली ये चीज बता रहा है कि सर्वर पे आपका जो कोड है ना वो कैसे रखा हुआ है। आप इसको सिंपल लैंग्वेज में इस तरीके से देख सकते हो। आपके EC2 इंस्टेंस के ऊपर हाउ यू आर हैंडलिंग योर कोड, on which path, whatever the required or whatever the prerequisite to run your code is available, is called a ping path or URL path. Okay. This is the advanced health check response timeout. This 2 second means your AWS EC2 instance is, let's say, whenever your load balancer is trying to communicate with your EC2 instance, and in 2 seconds, if it is not going to get the response on the load balancer, your health check will fail and your website will be down. Okay, first thing. Second is interval. What is the amount of interval between your uh, health check? Let's say right now is 9:50, 52 seconds. It is going to check again after 5 seconds. Okay, then it will going to check again after 5 seconds. So this is the interval between the to check the time between the health checks. Unhealthy threshold means, let's say your load balancer is trying to check the health of your EC2 instance, and for the consecutive 2 times, if it is getting failed, your load balancer will make your website down, or your instances behind the load balancer will be out of service, which means they are not going to serve the traffic. The healthy threshold means if your load balancer is going to communicate with your EC2 instance, and number of consecutive, let's say it, if it is getting 10 consecutive hits successfully, it means that your load balancer is healthy and your website is running fine, your EC2 instance is in service. Okay, now here you need to select the instances. We have not created the instances. So you need to select the instances once you create. Enable cross zone load balancing, enable connection draining, timeout draining. So that is a different thing. I'll tell you after some time for this. Okay. Now this is your configuration. This is a security group summary of your configuration. You just need to create the now. So our load balancer is created. When we see here, it says that the type of load balancer is classic load balancer created at this time. Three availability zones are there. It is showing the state as a dash because we have not attached any instance with it. So that is why it is showing us this dash state. Okay. So why it is uh, okay. Yeah. So once we attach our load balancers, okay, and our load balancers are performing well, so this state will be healthy state. But if we attach our instances and our instances are not performing well, this state will be unhealthy, and which may lead to your website in a downtime state. Okay, so this is your classic load balancer.